Okay, so I'm in here in SolidWorks and I created a new part. This activity is going to be working on creating a model of a parabola in the conic section. So we're going to see the cone, we're going to see a cutting plane going through it and how that creates a parabola. So first thing, we want to create a cone. The size of it doesn't matter that much, but I'm going to make mine 120 millimeters tall and 90 millimeters wide in total. So I'm drawing half the cone and then I'll revolve that. So go to features, revolve. My axis is that center line. It automatically selected that. If it didn't for you, go down to selected contours, click into that box and highlight the area you want to revolve. Make sure thin feature is not ticked either. So we can tick that, that's fine. And we can put a color on that if we want to. So I am actually going to put a glass color on this. And that just means I'll be fit to see what's inside it now in a second. So I have to create my cutting plane next. And to do that, for a parabola, I know that the cutting plane is always parallel to the edge of the cone. So I need to create a plane that's parallel to that edge there. So what I'm going to do is I'm going to create a base or sketch on that base, sorry, of a line going straight across off to one side. And that is going to be where my plane is resting. It's going to rest on that line. I can close that sketch. Now I'm going to start a sketch on the plane cutting through that. So the front plane is cutting through that line. Start a sketch on that front plane. I'm going to draw a line from that line on the base up at an angle and on past the cone itself. I'll rotate my view a bit. Now I'm going to make sure that bottom point is coincident with that line. So I'm going to pierce them together. And you can see the dot now is black. That means that point is fully defined. And I'm going to look back normal 2 again. I'm going to hold control, click the line, click the edge, that cone, and make them parallel. So the line is black as well, and this endpoint is blue, and that just means it has no proper endpoint. It can move up and down. That doesn't really matter to us. We'll be hiding them sketches in a moment. Close the sketch. Now I have 2 sketches, and I can create a plane using that because I have 3 points, 1, 2, and 3. So I'm going to go to Features, Reference Geometry, and Plane, and select each of them 3 points. Now, the normal is looking down the way. I don't want to be looking up from that direction. I want to be looking down. So I'm just going to go down here and click Flip Normal. So now we can kind of already see an outline of where that plane is cutting through the conic. Before I go any further, I'm going to hide them 2 sketches because I don't need them. Not for a while anyway. And the next thing I'm going to do is going to create that surface plane. Alright, so instead of just a plane, I want a surface plane. So I'm going to sketch on that plane, draw a rectangle. Alright, judge the size of this yourselves. It doesn't really matter as long as it's intersecting that conic. But just make it look fairly decent. It should extend slightly above that apex there. Alright, so I'm going to go to surfaces and planar surface. So you can see already where that is cutting through the conic there, and it's giving us that parabola shape. I'm going to hide plane 1, and I'm going to put an appearance onto the surface plane. And I want to make it transparent as well, so I'm going to use glass again. So now I can kind of see the outline there of the parabola. It's not as clear as I want it to be to show students. So what I'm going to do is I'm going to create a sketch and color in that sketch like we normally do. And there's an easy way then to get the intersection line between the two. So what you want to do is start a sketch on that surface plane. Go up here to convert entities and click the drop down arrow and click intersection curve. Then what you want to do is click the cone and tick that, and you'll see it draws in that curve for you. So it's a very handy tool, and you can see the parabola now a lot clearer and see that shape it's creating. So we can close that sketch and color it in. So go down, right click and say sketch color and make it something that has a good contrast to the background. And that is the sketch of our parabola. Now we've things to add in yet, like our focal sphere and our focal point and so on. And we also want to find the directrix and what actually makes that directrix. So we'll do that as well now in a moment. Okay, so now we're going to add in our focal sphere and find that focal point of the parabola. So what the focal sphere is a sphere that's inside that cone. So it's tangent to this cone, and it's also tangent to this plane. If we look along the plane as an edge view, it'll be tangent to both the plane and the cone, and the center point then will be along that center axis of the cone. All right, so we're going to draw that in now. So what I'm going to do is go on to the front plane. So whatever plane allows you to see that planar surface as an edge view. In my case, it's the front plane. And I'm going to draw a circle up here. So I'm going to click to draw a circle. And it doesn't matter about getting it perfect just yet. So we have the circle drawn in there. I want to hold control, click that, click the edge of the cone, and make them tangent. I want to do the same with the edge of the plane and make them tangent as well. Now it's still blue, that's because I can move it up and down. It doesn't really know where to stop. I want to tell it that this center point is directly below that apex there. So I'm going to hold control, select that point on the apex and say vertical. Now the line is black. Alright, so that means it's fully defined, it can't move. If I try to drag it, it won't move. Now draw a line down the center of that sphere, and we're going to use that to rotate it around. Features, revolve boss base, select our axis of revolution as the center line. I want to untick merge result and untick thin feature. So neither of them boxes should be ticked. Then go to selected contours, click into the box and click 1/2 of the sphere. Now you can see the preview of that sphere. If you're happy enough with that, give it a tick. And then now if I try to put an appearance, so I might put a plastic. If I try to put a plastic on that, it'll select the cone because that's inside the cone. So what I can do is go over here, take my appearance over here and go through the menu until I find the feature I need, which is that revolve to. So now we have our focal sphere inside the cone. Okay, so where that is in contact now with the plane that the ellipse is resting on gives us a focal point. All right, so we're going to have to use some kind of basic principles to find that now, our normal and so on. And as well as that, we can find our plane above here, which will give us the directrix. So that plane we used a moment ago, my front plane, okay, which we see this planar surface as an edge view. We're going to use that again, create a new sketch. And we want to find points of contact basically now with that sphere. So what I'm going to do is create a line going from the center of that sphere out to the plane with the parabola on it. And I also want to create one going from the center of that sphere out to the edge of the cone. Now I'm going to add relations, so that line and the edge of the cone, make them perpendicular, and that line and surface, or the surface plane, I'm going to make them perpendicular as well. Now you can see that this is still moving about. It doesn't really know where the center point is, so I need to make it concentric with that revolve. To do that, I need to hide this cone so I can get at the sphere and under it. Click the center point, click the edge of that sphere and make them concentric. Now you can see the lines go black again. I can close that sketch now and I can show that cone again. Right, go back and just show it. Now that sketch is only for construction, so I'm not going to color it. What I will do is I'm going to create a new sketch on the front plane again, on top of the line we already have now. So this is going to show how that focus is found. So just on top of that line, so it should be black, it's fully defined. And I'm also going to put a point there at the end of it here. And that is our focus. That's the focus of that parabola. And I can close that sketch, and in that sketch I'm going to color it. Again, try to pick some color that is nice high contrast to the rest of the colors you've used already. Now we need to create a new plane, and that's what this other line is for. So I'm going to go to whatever plane is on the bottom there, so my top plane. Open it up, hold Control and drag one of the corners up, okay? And then what I'm going to select is that top point of the line we're after creating. And you can see that cuts through the sphere now. So once I have that, what I can do now is hide that sketch that I created originally. I don't need that anymore. I'm going to create a planar surface, and I can see it's looking in the bottom of the object. I don't want that, or it's actually looking on top, that's fine. Just looked like it was looking on the bottom. Create a planar surface, a rectangle again, and we're going to keep the same width as the one we already have. Alright, it can be any length, but we'll keep it the same width as that. So to do that, if you see these bottom lines are a bit off, I can hold Control, select the corner of the planar surface I have, the corner of the sketch, and make them horizontal, and they'll line up, and do the same then on the top. So that just means if I went back and changed the original planar sketch or the planar surface, this one would update with it. I can make that into a planar surface now. And again, we want to make that something that's fairly see-through. So I'll go back to the glass and I'll pick blue this time. I can hide the sketch plane and leave us just with these planar surfaces. So now what I'm going to do is I'm going to get the line of intersection between the two planar surfaces and then the line of intersection between the surface plane here, the horizontal surface plane, and this cone. So I'm going to sketch on that planar surface, go to Convert Entities, click the drop down arrow and click Intersection Curve. And I'll click this other plane. So it's going to make a line where they intersect. Okay, so I'm going to close that and keep that as a sketch of its own. Change the color of that. I actually want to change that to black. And what that line now represents is the directrix. So if you remember from the drawing lab now what that directrix is and how it can be used, that's what it is in the 3D space now. So it's the intersection between them two planes, and that plane is created by making a tangent to the focal sphere, or in contact with that focal sphere. So create another sketch on the same plane, same thing again, intersection curve, and this time I'm going to select the cone and click tick. What that shows us now is where that plane is in contact with that sphere and the cone. Alright, so that's like a line of contact the whole way around. So you can change the sketch color of that. I'll make that something bright. Okay, and there is the model now of parabola. Inside the cones, we can see the cut surface, how it was made, and it was made by creating a cutting plane parallel to an edge of the cone. The focal sphere then is a sphere that fits inside the cone, tangent to the edges, tangent to that plane there as well. And the point of contact between that sphere and this surface plane gives us the focus of the parabola. The intersection then between this plane and that plane gives us the directrix. Okay, and that top plane there, or the horizontal plane, is found by creating a line of contact between the cone and the sphere. And that's the height it rests at then. Hopefully that makes a bit of sense. What I want you to do then is make sure to label the directrix, label your parabola, your focus, and you can label the two planes there as well. Right, that's just a cutting plane and a horizontal plane.